AP FTC. So in this video, we're just going to go over some AP questions. So let's start with question 3. The graph of the function f shown above consists of 6 line segments. Let g be the function given by g of x equals the integral from 0 to x, ftd. Remember, for this question, I actually like to write it out, what each thing equals. So g of x equals the integral from 0 to x of f of t dt. And that means the area, right? When you take an integration is just an area function. Then they want us to find g prime of 4. So take the derivative. G prime of x. You take a derivative of this thing, the derivative integration cancel out, you just sub in the x. You get f of x. That's a y value. And then they want us to find d double prime, so take the derivative one more time. Derivative f of x is just f prime of x. And that's the slope. Right? I like to do this so it lets me know when I'm doing it. Okay, just have a little key here to check every little thing I'm doing. I'm like, okay, that's what that means. So like the first one, g of 4. Right? So again, they just want to plug 4 into g. And then all you do is really just plug it into the equation there. So for that one, if I did g of, I'll do that right here. G of 4. Let's plug it into the equation. So 0 to 4, f of x. F of t, actually. So remember what, ooh, that looks ugly. There you go. Slightly better. So remember, we're finding integral from 0 to 4 f of t. So that's just the area from 0 to 4. So here's 0. Here's 4. So we got to find the area of all this. Now, area of this right here is a little triangle, so that's 1 and down 2. Area of a triangle is 1/2 base times its height. So 1/2, 1 and 2. Right? My height is 2. That's only 1. So I get 1. So this is -1 because below the x-axis. If you look at it here, though, this is actually the same thing. Right? It has the width of 1, height of 2. So this is also going to be 1. And actually, this is going to be the same thing. That's also going to be, so all I got to find is this middle here. And that's going to be 1 across and 2 up. So 1 times 2 is 2. So my area from 0 to 4 is -1 plus 1 plus 2 plus 1. So that's going to be 3. I'm just adding up everything from here to there. And that's the negatives below the x-axis. So that's the first one. It's g of 4. Now g prime of 4. Remember, look at my key here. That's the y value. So essentially it's just going to be f of 4. That makes it a little easier, which is just the y value. So f of 4, look at my graph here. F of 4 is 0. The y value f of 4 is 0. Next, I want g double prime. Looking at my key, g double prime equals f prime of 4. And that is the slope at 4. The slope at 4 is the slope of this line here. So you just got to find the slope. So down 2 over 1. -2 would be my slope, right? So just find the slope. You use points. I just do rise or run. So we went down 2, then over 1. So -2. This is my slope. So there you go. That's it. Now let's look at B. Does G have a relative minimum, a relative maximum, or neither at x equals 1? Justify your answer. So think about how do we find relative max or relative min or neither. Those are critical points. So we got to find a critical point. And the way we find critical points is where the derivative, in this case g, equals 0. Right, so those are my critical points, or undefined, I should say. These are my critical points. So, right, where does g prime equal 0 is where does f of x equal 0. So where the y value equals 0. So we have -1. We have 1, -1, 0. So let me know, hey, at 1, that is a critical point. Remember, all we gotta check now is does it go from negative positive or positive negative? This one goes from negative to positive, right? So negative to positive. If you remember, that is a local or relative min, and it goes down to up. I just gotta put that in words. So we're gonna say at x equals 1, g prime changes from negative to positive. G has the relative or local min. Right, so again, something to that effect. It's going to be exactly those words, but something to that effect where you say, hey, I know it changed from negative to positive. That's why it's a local min. So there's that one. Let's go to the next one here. It's probably the most complicated one of the bunch. Suppose that f is defined on all real numbers x and is periodic with the period length of 5. So remember, the periodic means it's going to keep on repeating itself. Period length of 5 just lets you know it's 5. So it's going like this, and then kind of keep on doing that all the way out. Graph shows 2 periods of f, so 1, 2. Given that g of 5 equals 2, Find g of 10 and write an equation of a line tangent, so I graph at that. Ooh, so lots going on here. Right, so write an equation of a line tangent, so I know I'm going to do y minus y1 equals m x minus x1. Like, that's my goal, to get there. And they want x to be 108, so this is going to be 108. So I still got to find the derivative at 108, and I got to find the y value at 108. So a couple things I got to fill out here. Given that g5 equals 2, let's talk about what that is. What does that mean? Remember, g is this equation right here. So this is just saying the area when I go from 0 to 5 of f of x equals 2. So look at our graph here. And yeah, that makes sense. If I find the area from here all the way to here, it does equal 2 because these cancel out. They're both 1, negative 1, positive 1. These cancel out, positive 1, negative 1. And all I get is the 2. So yeah, that fits. They want me to find G10. Remember, G10 is the area from 0 to 10. We're just plugging 10 into our equation right here of f of x. Well, we can look at the graph. Remember, it's periodic. So if I draw it again, I'll draw a short one so I can't fit, so I can fit it in. This would be 10. Well, I know all of this is 5. Sorry, I mean 2. That's what they told me. 2. And then all this must also be 2 then. So this is just going to be 4. So I know what G10 is. So G10 is 4. So that's one of the answers. G10 equals 4. Write an equation of line tangent, it's this right here, for the graph of g at x equals 108. So now I got to think about this. 108. Let me erase some of this mess here. So first step, I got to figure out where 108 is. So remember, it's periodic, so every 5. So let's divide 108 by 5. Right, because remember, all this thing is repeating every 5. That's why 10 is the same thing as 5. They're going to keep on repeating. So let's divide. So I get 2, I get 10, 0, bring the 8 down. 5 goes up 1 time. So 5, remainder of 3. So 21 remainder of 3. What does that tell me? That it goes around 21 times. There's going to be 21 rotations of this. I'm going to be left with a remainder of 3. So it actually works out pretty nicely. So to go over around 21 times, and it's to go 1, 2, 3. So this right here is the same thing as x equals 108. Okay, so let's go back to the problem, right? I gotta find the equation. So I have x equals 108. I know it's the same thing as 3. Let's find y of 108. So remember what the y value is just what do I get when I plug 108 into my equation. So it's essentially we're doing one of these guys again, right? Like I'm trying to find g of 108, which is just the integral from 0 to 108 f of x. Now, remember when we went 0 to 5 is just 2, and the 0 to 10 was 4? Every time we do it in a rotation, it's going to be 2 times. It's going to be a value of 2. Well, 108 is just doing a rotation 21 times. So this is going to be 21 times 2. Right? Because every one of these areas is 2. And I'm going to do it 21 times. Then I have a remainder of 3. So what does that mean? Well, that's this part. Let's add the remainder. Right, so I got to add up the area from here to here, from 0 to 3. Well, this part cancels out and I just get another 2. So it's going to be plus 2. So I get 42 plus 2, or 44. That is my y1. Right, that's a tough one. Right, because remember, y1 is this, what do you get when you plug the x into the equation? My equation is this integration equation right here. So I got to plug my 108 in, so I got to find the integral from 0 to 108. Well, how do I find that? Well, I know that these graphs repeat every 5, and I know the area of one of them is 2. So when I divided 108 by 5, I got 21 times, so it's going to be 21 times 2. But then you got to add the remainder, which is the same. We're going to add from 0 to 3. Well, luckily these cancel out, and I just get an extra 2. So 21 times 2 plus an extra 2, so 44. So not a little tough, but that's what you get. And then all I got to find now is the slope. Well, remember the slope is the derivative. That's what slope is. So go look at our key up here. The derivative is just the y value. So I need the y value at 108. Well, here's 108, same thing as 3. The y value is just going to be 2. So this guy is also 2. So I get y minus 44 equals 2 times x minus 108. And that's the answer to C. Both this guy and this guy. Okay, and the last one's a little tough, but let's move on. So here's another FTC question. It's from 2011. the continuous function f is defined on the interval negative 4 to 3. So here's our function f, continuous. The graph f consists of 2 quarter circles. So here's like a quarter circle, here's another quarter circle, small and big one, and one line segment as shown above. Let g of x be 2x plus the integral from 0 to x of f of t. And again, we have to find g and g prime. So as always, I like to write what those things are. G of x is 2x plus integral from 0 to x of f of t. And that's the area. When I plug into g to find the area. I'm going to take a derivative. Now this is a little trickier. The derivative of 2x, I got to take a derivative of that too. That's just 2. Plus the derivative of the integration. Those cancel out. You just get f of x. Remember, that's a y value. Or like a value. Now let's find the answer. So find a. Find g of negative 3. So all that means is we're going to sub it into the equation here, right? So straightforward. 2 times negative 3 plus the integral from 0 to negative 3 of f. Now part of this is easy, part of this is a little more complicated. So 2 times negative 3 is negative 6, easy. Integral from 0 to negative 3, remember that is saying what's the area from 0 to negative 3. If you notice this is going backwards though. We don't usually write that way, you go from low to high. So let me rewrite it. So this would be negative 6 plus negative 3 to 0. Right, since the limits were wrong, you had to go low to high, so I had to flip it. And then when I flipped it, I had to change the sign. So let's find the area from negative 3 to 0. Here's negative 3. Here's 0. That's a quarter circle. So the formula for this is just going to be 1/4 pi r squared. R here is 3. So this is going to be minus 1/4 pi times 3 squared. Or negative 6 minus 9/4 pi. So that's A. Well, the first part of A actually. Now I got to find g prime. Well, we already did that already actually. Right, g prime was just later take the derivative of 2x, which is 2, plus the derivative of this one, which just cancels out. You sub the x in, so f of x. So there's g prime of x, and now they want me to find g prime of 3. So this is plug 3 in there. Remember, f of 3 is just a y value, and here is 3. So y value at 3 is negative 3. So this is to be 2 plus negative 3, or negative 1. So that's A. Now let's look at B. Now I'm going to erase all this in a second just so I can do B. Determine the x coordinate of the point at which g has an absolute maximum on the interval negative 4 to 3. Justify your answer. Now this reminder says how do we find absolute max or min of anything. Remember, absolute maximum is a very specific formula. We check the critical points plus the endpoints and plug them into the original function. Whatever the highest values are max, or the lowest values are min. That's how we always find extreme values. It's an extreme values problem, right? So critical points plus endpoints, sub them into the original function. The original function in our case is this guy right here. So for B, let's first find, well, we have the endpoints already, which are negative 4 and 3, right? They gave it to us right there. Let's find the critical points. Remember the way you find critical points? You take a derivative, which we have our formula for up here, is just this guy right there, and set it equal to 0. So I'm going to set 2 plus f of x equal to 0, which gives f of x equals negative 2. So I gotta see where f of x equals negative 2x. That's going to be our critical point. So here's negative 2. We gotta figure out where does that hit this guy at. Now this is the AP test, so I can't just eyeball it and go, hey, it looks like it might be 2, or 2.3, or 2.5. You actually gotta do the math. So how do we do the math on this? Well, just like we did in Algebra 1. You gotta find the equation of this line and set it equal to negative 2. So let's find the equation of this line. I have 2 points. This point is 0, 3. This point is negative 3, 3. So I gotta find the equation line. Now you can do y equals mx plus b, or you can do y equals y1 minus blah. You can do this one also. Point slope form. In this case, I'm going to do this one because I actually have the y-intercept. It's 3. So it makes life a little easier. And then I can just plug negative 2 in front of y once I figure it. So let's find the slope, right? Just like in Algebra 1, slope is y2 minus y1 over x2 minus x1. Let's make this x2, y2. So I get negative 3 minus 3 over 3 minus 0. I get negative 6 over 3. So my slope is negative 2. So now let's solve this, right? I'm going to plug this, sub this in for the y, and I get negative 2 equals negative 2x plus 3. Do a little math. Negative 5 equals negative 2x divided by negative 2. X equals 5 over 2 or 2.5. Either is fine. So I have a critical point at 2.5. So again, we're trying to find the extreme value. So what we do is we get our critical points, 2.5, and our endpoints, and you plug them into the original function. So I got to plug it back into this guy here. So I got to find g of negative 4, g of 3. No one said AP Calc would be easy. G of 2.5, or short. It's a long problem. So g of negative 4, again, we're just going to sub it into the equation right here. So my equation to be 2 times negative 4 plus the integral from 0 to negative 4, if I remember that correctly. Yes. I'll write these out too, right? So it's going to be 2 times 3 plus the integral from 0 to 3. And then 2 times 2.5 plus the integral from 0 to 2.5. Let me erase this. I don't need this anymore. And then we'll focus on each one of these one by one. So let's do this one first. So that part's easy. It's negative 8. Now this one, I gotta find the integral from 0 to negative 4. So already you should notice our limits are the wrong way. So I gotta fix this. So this will be negative 8 plus negative 4 to 0 of f. So now I gotta find the area, because remember, integration is just area. So I gotta find the area from negative 4 to 0. So the area from here to there, these two. So those are both quarter circles. This is a quarter circle with a radius of 1. This is a quarter circle with a radius of 3. So this right here is going to be negative 8 plus negative version of those two quarter circles. So 1/4 pi r squared. And actually a little more, that's a negative quarter circle. So negative 1/4 1 squared plus, this is a positive quarter circle with a radius of 3, 1/4 pi 3 squared. And I get, let's see, negative 1/4 pi plus 9/4 pi. So I get 8 pi over 4, also known as 2 pi. So all of this was just 2 pi. But don't forget, there's still a negative in front of it. So I get negative 8 plus negative 2 pi. Whew. So that was g of negative 4. Negative 8 plus negative 2 pi. Now let's do the middle one. 2 times 3 is 6. And now I gotta find the area from 0 to 3 of f of x. So the area from 0 to 3. Now it looks like it's gonna be 0, but let's just double check real quick. Right, so this is 1.5, this is 1.5, this is 3 high, and this is 3 low. So yep, they're both the same, so they are gonna cancel each other out. So this is just 0, so I get 6 right there. So I have negative 8 plus negative 6, so negative 14-ish. That's not going to be the max. And then g of 3, which is 6. Last thing I do is I check this guy. So this is 2 times 2.5, or 2 times 5 halves, which is 5, plus the area from 0 to 2.5. Now that's going to get kind of ugly. So I got to find the area from 0 to 2.5. So let me erase this real quick. So here's the thing. We're going to find the area from 0 to 2.5. So 0 to 2.5, which is like right here. Now, from earlier, we learned this was 3 and 1.5. So area of that is 3 times, area of a triangle, 1/2 base times height. 3 halves is 1.5, so I get 9 over 4. So this is 9 over 4. I subtract off the area of this little triangle right here. Now, remember, this hits at 2.5. And if we want to find how the length of it is, I could use the equation right here. I know x is 2.5. Let's figure out the y, so let's plug it in. So y equals negative 2 times 5 halves plus 3. These cancel out. I get negative 5 plus 3, which is negative 2. So it's negative 2 high. I gotta find the length of this. I remember it happens at 2.5, but that's not how far it is. This is 1.5. and this is 2.5. So this is 1 across. So that makes area of this guy right here. Right, 1/2 base times height. So 1/2 -2 times 1. So -1. Again, it's a negative because it's below the x-axis. So my area for all these things here is 9/4, which is the same as 2 1/4, plus -1, which is 1 1/4. So go way back here to my 5, I add 1 1/4, and I get 6 1/4. Oh, those AP people are mean. So that is actually the max, right? It wins by 1/4. So my max is g of 0.25. But remember, that's the way you say it. Look at the question. The question was determine the x coordinate of which thing has an absolute max. So x equals 2.5 is the absolute max. And your justification is all the work you did, as it should be. So that is B. So now let's talk about C and D. Now, I'm going to erase this in a second, but let's talk about what C is. So find all values on the interval -4 to 3 for which the graph of x has a point of inflection. Give a reason for your answer. Okay, this one should be a little easier. Now it's all clean. So we were trying to find a point of inflection. So again, a lot of it has to do with us understanding the definition. So point of inflection, let's do C down here, is where the second derivative, again, our function is g, so it's where g double prime is equal to 0 or undefined plus a sign change, right? It's all about definitions. Now, I don't think we found g double prime yet, so let's look up here in my key. Yeah, I only have g prime, so g double prime, so derivative both sides, derivative 2 is 0, derivative of x is f prime of x. Remember, that is the slope. So we're trying to find, we know g double prime of x equals f prime of x. We're trying to find where the slope equals 0 or undefined. And a sign change. So the slope equals 0 or undefined at 3 places. Here, that's a vertical tangent line, so that does count as undefined. And we have right here, we have a cusp, but it's undefined there too. Now, you can't say that it's an endpoint, so that doesn't count. So we have a -3 and we have a 0. Now we need a sign change. Now remember, we're talking about slope here, right? We're talking about f prime of x, we're talking about slope. So where does the slope change sign? So if you look right here, at this one, my slope goes from positive to positive, so there's no sign change there. If you look here at 0, it goes from positive slope to a negative slope, so that's where the sign changes. So we're going to say, again, they wanted the x value, so we'll say x equals 0 is an inflection point because f double prime is undefined, sorry, g double prime is undefined, and g double prime changes signs. Right, so this is what we talk about. Just using the definition now, right? Where's the inflection point? It's where the second derivative equals 0 and then undefined. So this is where my second derivative equals 0 and is undefined. We need a sign change. Keep in mind we're talking about slope. The second derivative is about slope. So my slope goes from positive to positive. And over here my slope goes from positive to negative. So that's the one that gives us the sign change. Now let's look at D for a second. So D says find the average rate of change of f on the interval -4 to 3. So let's do that first. Average rate of change. Remember, that's just the slope, like good old algebra 1 slope. So average rate of change, we're just going to do the slope y2 minus y1 over x2 minus x1. Of course, here we tend to write it as, and we'll write that as 3 minus -4. And so we're talking about f of 3 minus f of -4. Let's sub in our values. F of 3 is right here. Here's our graph of f. So f is just this graph here. So f of 3 is this -3. Likewise, f of -4 is just right there. So -1. And then we get 3 minus -4. Again, we're in AP Calc, so we can just leave it. That's a perfectly acceptable answer. So that's the first part. Now let's talk about the second part. There is no point C where C is between -4 and 3 for which f prime of C is equal to that average rate of change. It's only the statement does not contradict the mean value theorem. So you have to go think back, what does the mean value theorem say? Mean value theorem says that if a function is continuous and differentiable, and then if you have like an interval here from a to b, I would say on a to b, there must be a derivative. There must be a derivative that equals the slope of the endpoints. That's the mean value theorem. right? They're saying if you have a continuous differentiable function on a, b, and then there must be a point between that a and b where the derivative equals the slope of those endpoints. Now, why isn't this contradicted? Well, it's the first part, right? This first part has to be true. What's not true about this first part here? It's not differentiable right there. So that's why it doesn't contradict it. So this statement, you gotta say why. Does not, this is part 2 of this, does not contradict MBT because f of x fails to be differentiable at x equals -3 and x equals 0. Remember, you gotta give some reason. You can't just say, you gotta explain why. So there's our explanation. So there's that problem. Next one. So last problem we're gonna do here is from 2003. The figure shows the graph of f prime. So keep in mind, this is f prime, not f. It's f prime. The derivative of a twice differentiable function on the closed interval 0 to 8. The graph of f prime has horizontal tangent lines at 1, 3, and 5. So 1, 3, and 5 are horizontal tangent lines. The areas of the region between the graphs of f prime and the x-axis are labeled, so they give us all the areas. This is 2, 6, 3, and 7. The function f is defined on all real numbers and satisfies f of 8 equals 4. That's going to come into play in a second. Find all values of x, which is the open interval. So question A. Find all x values on the open interval between 0 and 8 for which the function f has a local minimum. Just for answer. So for this one, remember, you got to think back, how do we find local min? Remember, those are my critical points that go from negative to positive. So for A, first you got to find the critical points. Now remember, the critical points were the derivative equals 0. Hey, look, we have a derivative. So where does it equal 0 at? At 1, at 4, and at 6. So my critical points are 1, 4, and 6. So at 1, we go from positive to positive, so that's a neither. At, what was that, 4, we go from positive to negative. That's a max. And at 6, count, we're negative positive. So that's our min. So we're going to say they want to find the x value. So x equals 6 has a local min, or relative min, because f prime goes from negative to positive. And that's it. Done. Now let's look at B. B says determine the absolute minimum value of f on the closed interval 0 to 8, justify your answer. So we're doing absolute min. So remember, that's an extreme value. So we got to find an extreme value. And that never changes. The way we find it, it's always critical points plus endpoints, and then plug them into the original function. In that case, that's our f of x. So for B down here, we're going to check our critical points and our endpoints. Now my endpoints, 0 and 8, they gave it to us. So I've got to figure out what f of 0 is. I got to figure out what f of 8 is. And actually, I know what f of 8 is. They gave it to us right here. f of 8 is 4. Now my critical points. Now remember, we found out in the last one, my critical points are right here. It's 1, 4, and 6. So those are my critical points. We know 1's a neither because it goes plus to plus, no sign change. We know 4 is a max, it goes from positive to negative. And I know 6 is a min because it goes from negative to positive. We're looking for absolute min. So actually, the only one I got to check is 6. So we have this. Now we know f of 8 is 4 because they gave that to us. But how do we find out f of 0 is? We have f prime here. We don't have f. So this is where we're going to use a trick. We're going to use a trick we're going to use the FTC 1 trick. And that is this. If I want to find f of 0, I can use the fact that I know f of 8 equals 4. And we're going to do this. We're going to integrate f prime of x from 0 to 8. Now, why did I pick 8? Well, because I had to pick 8 because I know what 8 is. And I picked 0 because that's what I'm looking for. And why did I write 8 up there, 0 down there? Well, because remember, we go low to high. So 0 has to go down there, 8 has to go up there. So why do we use this trick? Well, what happens when you integrate f prime? You get f. And then we do limits, right? So top minus bottom. This is the same thing as saying f of 8 minus f of 0. That's what this equals, right? When you integrate f, you get the original function, and then you subtract your limits, top and minus bottom limit. And this, so now all you gotta do is find f of 0. I know what this is. That's 4. They gave that to me. This is what I want. And this I could find. How do I find that? Well, that's just the area from 0 to 8. And look at my graph here. They gave me everything I need for that, right? They gave me the area from 0 to 8 is this guy 2 plus this guy 6, so 8, minus this negative area, so 5, plus 7, 12. Right? So this is just 2 plus 6 minus 3 plus 7. That's the integral from 0 to 8 of this function. So now I have this like little equation here. I have 12 equals 4 minus x. Do a little math. 8 equals x, or 8 equals f of 0. So now I know f of 0 equals 8. I could do the exact same trick to find f of 6. So again, this is a trick I want you guys to get used to doing. So if I want to find f of 6, I'm just going to do this. The whole idea is like I need to find f of 6, but all I have is f prime. So how do I find f of 6? Well, you integrate f prime. Again, I know f of 8 is 4, so put 8 up there and 6 down here. Why 6 on the bottom? Because 6 is lower than 8. Why am I using f of 8? Because I know it equals 4. When you integrate this, you're going to get regular f, and then you're going to subtract the limits. 8 minus 6. So f of 8 minus f of 6. Again, this I could find. This I know. That's 4. And this is what I'm looking for. So I got to find the integral from 6 to 8. Integral from 6 to 8 is 7, based on the graph right there, because it's this area. So 7 equals 4 minus f of 6. Do a little math, and you get 3 equals negative f of 6, or f of 6 equals negative 3. And that is B. So let's look at C. On what open intervals contained in 0 to 8 is a graph of f both concave down and increasing? Explain your reasoning. So this one's actually more straightforward, just definition, right? Increasing is where the derivative is positive. So where's the derivative positive? Well, here's my derivative. I have the derivative graph, so it's just where it's positive. So that's here to here, from 0 to 1, here to here, 1 to 4, and from here to here, 6 to 8. So that's where my derivative is positive. How about concave down? Right, concave down is where the second derivative is negative. Now I don't have the second derivative, I have the first derivative. So you gotta think, okay, wait, how do I go from first derivative to next derivative? How do I find concave down when you have the first derivative? That's where f prime is decreasing, right? Where f prime is decreasing, that's where the second derivative is negative. So look at your graph. Where's it decreasing at? From here to here, and from here to here. So where's it both decreasing and positive? Well, that'd be right here, from 0 to 1, and this whole part right there, from 3 to 4. And let's not forget to explain our reasoning. So we already said it. It's because this is where f prime is decreasing, and where f prime is positive. That's all it is. Right? Like this mistake people make is that they do these separately. They go, oh, concave down is here and here, increasing to here, done. No, they want the intersection. Where is it both this and this? So now let's look at D. D, the function g is defined by g of x is equal to fx cubed. If f of 3 is negative 5 halves, find the slope of the line tangent to the graph of g at x equals 3. Find the slope of the line tangent. A lot of people always try to find the equation of a tangent line. That's not what it's asking. Find the slope of the line tangent. This is a fancy way to say take the derivative. So they want me to take the derivative of g at 3. So they want me to find this essentially. Okay, well, let's find that. Now remember, when we take a derivative of g, you do not let this 3 here is the last thing you do. Last thing you do is plug it in. So first, let's just find what g prime is. G prime is my favorite type of derivative. It's a chain rule. Notice how the f of x is inside the 3. So we do a chain rule. Take the derivative of the outside. Leave the inside alone. Times by derivative of the inside, f prime of 3, x. So we get this, right? That's my derivative. That's a straight up derivative. Bring 3 down, subtract 1 off, leave the inside unload, times it by derivative of the inside. Now we can plug in that 3. And let's see what that does for us. We're going to get g prime of 3. This means to sub in 3 for everything, all the x's. And we just got to simplify this to get a value. F of 3, like, how do I find f of 3? Well, actually, they gave it to us. So it's just going to be negative 5 halves squared. I need f prime of 3. Now remember, we have f prime with we have the f prime graph. So f prime of 3 is just 4. And you get this. And since we're in free response in AP Calc, we are done. Don't need to simplify.